Welcome back. We are now finishing the second half of your midterm review. Question 8, a particular brand of sparkling water launched their company in 2004 with 6 sparkling water flavors. Over the years, they have introduced new flavors. The table gives information about the number of sparkling water flavors available by year. So in 2004, they had 6. Then 2008, they had 7. 2011, they had 8, and so forth. So the question is, on average, how many new flavors were released per year between 2004, so let's mark that off, 2004, which is right here, and 2011. So we're looking between these years, right here. So on average, so you just find the slope. It's going to be the change, it'll be 8 minus 6 over 11 minus 4, or 2011 minus 2004. That's going to be 8 minus 6 is dose, or 2. 2011 minus 2004 is 7. So it's a kind of a weird average rate of change, but it's 2 flavors for every 7 years. So it's flavors per years. So obviously, they introduce less than 1 flavor per year on average. On average, how many new flavors were released per year between 2018 and 2021? That's these years. That's going to be 20 minus 14 over, 21, 18, that's going to be over 3. That's going to be 6 over 3. That's now 2 flavors on average per year on that interval. So they were picking up the pace on the number of flavors. All right, question 9. You're just supposed to evaluate this piecewise function for different values of x. And so they want you to evaluate at h of -4. So we use the inequalities here to decide which piece to use. -4 is less than -1. So that means we have to use the top piece. So that is going to be 3x plus 5. X is -4. And so this equals 3 times -4 is -12 plus 5 is -7. So this equals -7. Now they wanted us to find h of 10. 10 is bigger than -1, so we have to use the bottom piece. So that was x squared minus x. X is 10. So that equals 100. 10 squared is 100 minus 10 is 90. So h of 10 is 90. Okay? Find the y-intercept of the graph. You have to remember, y-intercept is when x equals 0. That's the key to unlock this part of the question. So when x is 0, this one might be a little bit tough. Is 0 larger than or less than -1? So think about this. Here's 1, here's 0, here's -1, and -2, and 2. All right, so here's -1. That's the handoff. 0 is to the right of -1. That means 0 is larger than -1. So we're forced to use the bottom piece. Even though a lot of times kids get hung up and they get confused and they think -1's larger than 0. They think 0 is the smallest number, which it's not. Okay, so you end up with 0. H evaluated at -1. This is when you have to look at the inequality. Okay, it's exactly -1, so that means we have to use the or equal to, which is the 3x plus 5. So that's 3, -1 plus 5. That equals -3 plus 5, which is 2. All right? That's question 9. Question 10. Consider the pattern shown and assume it continues forever, I guess. How many blocks will there be in figure 6? Well, there's 1, 2, 3. So this is 3. 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5, 6, 7. And that's 7. I'm just writing down the number of blocks for each of these figures. You see there is a constant rate of change. We keep adding 2 each time. So when they say how many blocks will there be in figure 6, and we're at 3, so 3 was 7, 4 is going to be 2 more, 9, 5 is going to be 2 more, is 11, 6 is going to be 2 more, and it's 13. So in figure 6 equals 13. I just kept the pattern going, adding 2 each time. Okay? And this was that was the figure number, 3, 4, 5, and 6. Okay. Is the pattern formed by the number of blocks in each figure linear or nonlinear? It's linear. Has a constant rate of change. Okay. Question 11. If the pattern shown is linear, determine if the pattern shown is linear or nonlinear and explain. All right. So we add 4 when we add 2 to the top. So that rate of change is going to be 4 over 2, which is 2. Here, we add 6 when we added 3. That rate of change will be 6 over 3, which is 2. Here we added 2 when we, did I say add? I'm sorry, we're subtracting. So that was actually a negative 4. 16 to 12 is negative 4. 12 to 6 is negative 6. 6 to 2 is negative 4, whereas we changed by 2, and that's negative 2. So as you can see, the rate of change is always the same. It is linear because it has a constant rate of change, which basically means it has a constant slope. Okay? All right. On this one, all you have to do, you're given a piecewise defined function. You have to evaluate it at these different values of x. So at negative 2, which is right here, we're at negative 1. It's pretty easy. At x equals negative 1, it's a little bit trickier because negative 1 is where they hand off. It's right there. What you have to look for, and this is why this is tricky, you see, you have to look for the closed part of the circle, because the closed part is is or equal to. So at negative 1, it's where they hand off. The closed part is upstairs at 2, not down there at the bottom at negative 1. So this is actually equal to 2. F at 4.2 just means we're over here in between 4 and 5, and we're down there at negative 4. Okay. Question 13. All right, we're coming home. And I can go home after this. The best way to do this, the first thing you got to remember, you would have just seen this before the midterm, all right, is that absolute value graph function has graphs that look like V's. Okay, it's going to be a V. So let's plot these points and see what kind of graph it gives us. Negative 3, 1, 2, 3, 4, 5 is right there. Negative 2, 1, 2, negative 2, 4. So negative 2, 1, 2, 3, 4 is right there. Then 0, 2. And then all of a sudden they jump over here to 4, 0. and 5, 1. Don't let that confuse you, because that could throw you for a loop, understandably. All right? What you want to do is, I'm going to try to use the built-in ruler. There we go, so you can see it on the screen, but I've been having issues with it. You see this half forms a straight line, so I would just draw that straight line. Okay, and then those 2 points, obviously any 2 points will form a, oh, come on, James, will form a line. Why is it doing this? There it goes. And my screen moved on me. They cross right there, if you were more careful than I was. So the where's the vertex is where those 2 lines cross. It's 3, -1. All right, the last little bit, the last question. Dun, 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 14. Solve these absolute value equations. We actually did this last semester at the end. But in this curriculum, I didn't know where this was covered. In this curriculum, it's covered right here. So remember, the absolute value makes anything on the inside. If the absolute value of -3 is 3, the absolute value of 3 is 3. So what it basically says is, if the absolute value of 4g equals 8, that means the inside, the 4g, can be actually equal to 8, but it can also be negative, because the absolute value changes that -8 into a positive. So solving each of them, you get 2 or -2. Likewise, all right, the absolute value of z plus 5 equals -10. I hope you guys realize that when you take the absolute value of a number, it is always positive. Well, this is saying the absolute value of an expression, of some output that's a number, is equal to a negative. That's no bueno. You can't do that. That's, as they would say, illegal. So no possible solution, or no solution. The last one is saying that the absolute value of n plus 1 can equal 5. So that means if n plus 1 can either equal 5, because when you take the absolute value of 5, you still get 5, or the n plus 1 can actually equal -5, because when you take the absolute value of -5, you get 5. This leads us to 2 solutions, 4 and -6 as our 2 solutions. And the reason we get 2 solutions again is because the graph of an absolute value is a V. All right, so anyway, that's it on your midterm review. Goodbye.